Okay, so we're going to be doing a lesson here on section 5.4, which is some applications of the trig functions that we've been talking about. So one big idea we need to know right away is this idea of angle of elevation versus angle of depression. So when we measure things, it's a common way that we're going to talk about it. Angle of elevation is always starting at the bottom, whatever that horizon is, and looking up. And then angle of depression is always starting at the top and looking down. And one thing you'll notice about these two is that they are congruent. So you can really draw things either way. But angle of elevation start at the bottom and look up. Angle of depression is starting at the top and looking down. So as we cite things, just something to keep in mind. So our first example we're going to do, maybe some of you have been to Vegas and have seen the Stratosphere Tower. They have rides up there. It's crazy. They have like a roller coaster, some other things. So here's an example that has to do with that. So it says the angle of elevation of the sun, so meaning like if there's a shadow casting on the sidewalk, the angle of elevation is 65 degrees. That means from the bottom and then looking up. So there's your 65 degrees in the bottom. And it says the shadow cast by that tower is 535.8 feet long. What would the height of the tower be? Is that enough to do? So a lot of this is this indirect measurement, right? We wouldn't, to figure out the height of the tower, we wouldn't want to crawl up the tower and try to measure it that way. We're going to measure it from things that we can measure easily, which is standing on the ground, looking up, and measuring flat distance on the ground. So maybe you've seen surveying equipment like that. So which trig function should we use to find the height? That's the side opposite the 65. We have adjacent, and that would be, let's see, tangent. So we have tangent of 65 degrees is equal to h over 535.8. And we're going to go ahead and multiply and get our height. So I believe that was 226.4 feet. You can double check my arithmetic. I'm hoping I use the right one there. So just multiply. So we're just trying to set up the right trig ratio that would solve it best for us. So look at what we have and what we're trying to find, and then use that trig ratio. So things that are not easily measured. Okay, we'll try another one here. Another example is using geometry. It has a lot of different things with right triangles in it. One idea you talked about back in geometry was an apothem. An apothem, we'll use letter A for that. An apothem is the perpendicular distance from the center, make it in blue here, to any one of the sides. That's the A, or the apothem. So it's the perpendicular distance from the center to the midpoint of one of the sides. So I'm going to make this a little bit bigger, this little triangle that I just made, so we can talk about this idea a little bit easier. So that's our apothem. If there's a regular octagon, that means there's 8 sides. Regular means all the sides are equal. So if I tell you that the perimeter is 56, and it's regular, that means 56 divided by 8 would be the length of a side, so that's 7 inches. Well, now in our little triangle that I drew, so this blue one that I made bigger over there, that means this is only half of the side, so that's where that 3.5 came from. All right, now the last kind of missing piece, and you're going to have to do this on one of them on your own, is trying to figure out what this angle measurement would be. So all the way around the circle, if I did the entire way around, that would be 360 degrees, right? So you just have to figure out how many of those little triangles would we have all the way around. Well, there's 8 sides, and there's 2 triangles per side, so there would be 16 of those little triangles. So if you take 360 degrees divided by 16, we get our 22.5 degrees. Okay, so let's see if we can figure out what trig ratio we would use then if we want to find the A, or the apothem. Well, we know this angle up here, it's the adjacent side, and we know the opposite. So opposite and adjacent is tangent again. So we would say the tangent of 22.5 is equal to opposite 3.5 over A. Now some people really kind of struggle when the A is in the denominator or the variable's in the bottom. I'll go ahead and just times by it. So times both sides by A. We'll cancel over there. So A times the tangent of 22.5 is equal to 3.5, and we're going to go ahead and divide. So divide by tangent of 22.5. And we should be good to go. So your A value, or your apothem, would be 8.4, and that was in inches. And then you could find anything else you wanted to as well. You could find the radius because you'd know 2 sides. So the whole idea is setting up that right triangle and figuring out, okay, what side do I know and what am I trying to find? All right, so next one. So I have the picture for you. So we have this ramp. The height of it, the vertical height is 12 inches. The angle of elevation between the ground and the ramp is 17 degrees. How long is the ramp? So we know the side that's opposite, and we're trying to find the hypotenuse. Well, that would be sine. So the sine of 17 degrees would be 12 over L. So here we have this situation with the denominator is where our variable is. So I'm going to go ahead and times by L. And some people kind of figure out the shortcut here that you're always going to be dividing then. So L times the sine of 17 degrees, divide by the sine of 17. Make sure you're in degree mode for all of these. And we divide, we get L is about 41 inches. I think that's rounded. Okay, so you're just looking for that right trig ratio to use what you have and what you're trying to find. Okay, so let's see if we can draw a picture for this one to kind of put this together. So what we're looking at is somebody who's 6 feet tall, and they are measuring the angle of elevation to the top of a tree. So I'm going to go ahead and draw a picture. So I'm going to draw a lovely tree. You guys can draw yourself a lovely tree here. And this biologist is standing somewhere over here, and he's 6 feet tall, or that's where his eye level is. And he's sighting to the top of the tree an angle of elevation to be 38.7 degrees. So from his eye level, that's how tall he's sighting it. Now he is standing 180 feet away. And the question is, what is the height of the tree to the nearest foot? So we're looking for H. Okay, now when you think about the situation you still have a right triangle. His sight line, still a right angle there, is still going to be 180 feet. So I can go ahead and use that triangle on top, so from his eye level, so this blue one, and calculate that part of the height. So I'm going to do that first. So I'm going to call this part in this triangle right here the x. So I want the opposite side. I know the adjacent, so that's tangent. So the tangent of 38.7 is equal to x over 180. Just multiply, we'll get our x, which is, let me find my number here, looks like 144.2, and that would be in feet. Now, is that the height of the tree? Well, no, because he was doing that from 6 feet tall, so remember, same thing as he's standing over here, so we need to add our 6 feet onto that, which is that height, so we'd be at 150.2 feet, or just about 150 feet tall. So just got to be careful when we do these sightings. They always have to calculate that in there. Okay, the last few questions here are just practicing really quick with knowing which ratio to use and putting in the information that you have. So we'll do this real quick. If A is 38 degrees and little a is 14, they want you to find C. So you have opposite, you want hypotenuse, so that would be sine. So sine of 38 degrees would be equal to 14 over C. Again, we're going to multiply by C and then divide. So we'd have 14 divided by the sine of 38. And so C would be 22.7. Just practicing to make sure we know which one to use. So kind of zip through these. Angle B is 58 degrees, and we know C is 32, and we're trying to find little a. So we want adjacent. We know hypotenuse. So that would be cosine. So cosine of 58 degrees would be little a over 32. We can just multiply. So 32 times the cosine of 58, and that would be about 17. So little a would be 17. Remember, you always want to think about what's reasonable. The longest leg should always be your hypotenuse. Okay, little b is 45. Angle B up here is 72, and they want you to find little a. So you know opposite, you want adjacent, so that would be tangent. So tangent of 72 is equal to 45 over a. Again, we got to get that a out of the bottom, and then we're going to divide. So a times the tangent of 72 equals 45, and divide by tangent of 72. All right, so little a would be 14.6. So it's all a matter of just knowing, okay, which part of the triangle am I looking for? All right, last one of these. So we get to practice our degrees minutes. So 50 degrees, 45 minutes is angle A. Side C is 27, and we're trying to find little b. So we want adjacent, and we have hypotenuse. That would be cosine. So cosine of 50 degrees, 45 minutes would be b over 27. We just multiply. So be careful when you type that in. So 27 times cosine of 50 degrees, 45 minutes. Use your angle menu. And little b looks like would be 17.1. So shortest leg across from the smallest angle. Just make sure those seem reasonable. Okay, last one. We're going to go ahead and do our regular apothem here again, and to see if you can draw the picture. I made a hexagon for you, so 6 sides. It says it has a side length of 8 centimeters. Find the length of the apothem to the nearest tenth. So remember what the apothem is. Perpendicular distance to the midpoint of one of the sides. I'm going to go ahead and make a right triangle out of this. All right, so I'm going to draw this a little bit bigger over here. So if the entire side is 8, that means to the midpoint that would be 4. We don't really know a whole lot else. We're trying to find that distance, but we can figure out this angle. So we have to figure out how many of those triangles would we have going all the way around. If it's 360 the entire way, how many little triangles would we have? Well, there's 2 per side, 6 sides, that would be 12 little triangles. So when we divide, that would be a 30-degree angle. So our angle here is 30. So if we want the apothem, that's the adjacent side we want, or that we want, and then we know the opposite. So that would be tangent again. So tangent of 30 degrees is equal to 4 over a, so opposite over adjacent, multiply by your a, your apothem, and then we're going to go ahead and divide by tangent of 30. All right, so we divide by tangent of 30, and our final answer then for the apothem would be 6.9 centimeters. So there's our apothem. So when we're doing our problem solving, it's really important to always think about which side am I looking for, what side do I know, and what trig ratio can I use to find that in a right triangle.